An interstellar invader has arrived. Again. This summer, telescopes and news headlines have been pointed at the sky, all asking the same question. What is 3I Atlas? Our best eyes in space have all been scrambling to catch a glimpse, and what we've seen has been strange, to say the least. What's really going on with 3I Atlas and its 7 anomalies? Is it just a unique space rock, unlike any we've seen before? Or do its bizarre trajectory, staggering speed, and odd chemical makeup hint at an extraterrestrial origin? Will it perform a disappearing act in spaceship-like maneuvers as it passes behind our sun, or simply burn up in its race? Plus, why have cultures feared comets for millennia? And could a NASA-funded project one day convert asteroids into spaceships? Join me as we unravel some of these questions and more, and enter the Codex Legendarium. I'm Shelby Melanson. Three I Atlas. It's one of just 3 objects we've ever spotted in our solar system that came from outside our solar system. We first got wind of it on July 1st through NASA's Atlas Survey telescope in Chile. But by the time we did, it was basically in our backyard. So why didn't we see it sooner? Based on its flight path, we think that it came from somewhere in the center of our Milky Way galaxy, an area called the Thick Disk. Suffice to say, there are a lot of very bright stars in that part of the galaxy, making objects way harder to spot. To reach us, 3I Atlas would have had to travel 26,000 light years, meaning it may have been traveling through the cosmos for upwards of 7 billion years. That would make it the oldest comet we've ever seen, and at least 3 billion years older than our sun. So, no big deal. As if that wasn't enough, it's speeding through our celestial neighborhood at an eye-watering 137,000 miles per hour. That's 37 miles in a second. Its arrival has sparked massive debate, just like our first ever interstellar visitor, 1I Oumuamua, did back in 2017. But if Oumuamua was odd, 3I Atlas is downright baffling. One of the biggest voices in that discussion is Harvard physicist Avi Loeb. According to him, there are 7 things that make this object weird. So weird that he says there's a 40% chance it might be technological, as in not man-made, but something-made. Some of these anomalies are unusual, but could in theory be explained away by new data in the future. But others will, in Loeb's words, remain puzzling forever. 3I Atlas is big, like unexpectedly big, with a mass of around 33 billion tons. In SI units, that's 33 trillion kilograms, 33 with 12 zeros. Estimates put it at roughly 3 miles or 5 kilometers in diameter, roughly the width of the island of Manhattan. And that's just the nucleus, by the way, not the coma. Being that big, and since small objects are by logic more common than larger ones, you'd expect 3I Atlas to be one of thousands of interstellar objects that we've seen. But it's not. It's only the 3rd ever. Some suggest that's because smaller objects can't survive the harsh journey to get to us. On the other hand, an astronomer at the Lowell Observatory in Arizona said the lack of smaller interstellar objects is, quote, telling us something, but we don't know what that is yet. In general, comets have tails. Those eye-catching trails of light that stream behind the nucleus. They appear as ice and other material evaporates as the comet nears the sun, sending gases and dust particles flying. And while 3I Atlas did start growing a standard comet tail as of August 27th, before that it had, and still has, something called an anti-tail. Basically, it's a tail, but pointing toward the sun, not away from it. They're also called forward jets, or sunward spikes, and they're only visible when a comet passes Earth's orbital plane, the fancy name for the imagined flat surface that Earth rotates on around the sun. Comet antitails are effectively an optical illusion, caused when the sun lights up particles around the comet and makes them look like they're spiking toward the sun. A handful of comets in the past few decades have had them. The most recent of them passed by us in October of last year, called Comet C 2023 A3. Here's a photo of it I took myself. But the anti-tail on 3I Atlas isn't caused by a trick of the light. Instead, it's thanks to large dust particles getting ejected, but not getting swept up by solar wind and forced into the tail. Avi Loeb says this kind of anti-tail is so unique that it may not have been previously observed, like ever. Though there is some debate about that from other scientists. Coming in at number 3 on the anomalies list, a light signature so unusual that it's being called the only example of its kind. It's called polarization, or the light that makes the comet glow. In a paper submitted to the Astrophysical Journal Letters, researchers reported that 3I Atlas shows, quote, an extremely deep and narrow negative polarization branch. More simply, its light behaves differently from every single other known comet ever recorded, either from our solar system or otherwise. It's so weird that it suggests 3I Atlas might be the first in a brand new class of interstellar celestial bodies. It also means it has a lot more in common with deep space objects in the Kuiper belt than it does with other comets. On August 6th, the James Webb Space Telescope used its near-infrared spectrometry instrument to catch a glimpse of 3I Atlas. A day later, NASA's SPHEREX Space Telescope did essentially the same thing. Just for fun, its full name is the Spectrophotometer for the History of the Universe, Epoch of Reionization and ICE's Explorer. A+ tongue twister, NASA. Anyway, the tools measure how infrared light radiation, that's beyond what our human eyes can see, interacts with matter, and that info can tell us what a space object is made of. Here's what they learned. The gas cloud or coma surrounding 3I Atlas is 87% carbon dioxide and just 4% water. That 8-to-1 ratio is among the highest ever observed in a comet, and 6 standard deviations above normal levels, according to a September 11th paper. As if that wasn't enough, an update from September 30th revealed the object is now shedding around 88 pounds of water every second. That's about as much as a fire hose turned up full blast. As for why any of that matters, it suggests that 3I Atlas was exposed to extremely high levels of ultraviolet radiation in whatever star system it formed in, which, by the way, might not even exist anymore. And that radiation is way higher than what comets inside our solar system come to terms with. That brings us to another pair of elements, nickel and iron. They're typically found together in solid form in the core of comets, because they're both created during supernova explosions, aka when stars die. Here's the thing. Early observations saw plenty of nickel, but no iron whatsoever. That raised some eyebrows because, well, you know what else shows nickel with no iron? Metal alloys that are made industrially. That said, we did start to see a little bit of iron appear later, plus a lot more nickel, but only when 3I Atlas got way closer to the sun. Before that, the fact that we could detect it at all when it was still so far away from the sun, scientists say that shouldn't have been possible. That's because the surface temperature of the comet's nucleus is way too low to vaporize them. And yet, 3I Atlas has them. A lot of them. A study published October 1st calls this extreme abundance ratio of metal extremely puzzling, adding that, compared to comets in the solar system, Comet 3I is either metal-rich, or, more likely, it has enhanced metal production due to chemical anomalies. One last bit of chemical weirdness. As 3I Atlas got closer to the sun, we also spotted a major increase in cyanide in its coma. So much that theories say it's responsible for turning the coma from red to blue-green around September 7th. That theory is unusual too, because it's usually C2, diatomic carbon, that makes comets green, and 3I Atlas is among the most carbon chain depleted comets known. That's the end of the first category of anomalies, things that are odd, but that in theory could be explained away with new data. Now let's get into the ones that maybe can't be. A quick point on part of why I think people are so fascinated with this whole interstellar saga. It's totally reasonable to expect that a celestial object from somewhere very far away in our universe probably looks a little different than what we're used to, and that it would have a few anomalies. But things start to get interesting when you start layering oddity on top of oddity. One unique feature is a scientific marvel, but 3 4, 5, 6, 7 unique features, the likelihood of those odds starts to shrink and eyebrows start to get raised. Even though 3i Atlas is, thankfully, not on a collision course with our pale blue dot, its trajectory and the timing of it are still unsettling. Ready for some astrophysics? 3i Atlas has a hyperbolic trajectory, meaning it's impacted slightly by the pull of our sun's gravity, but it has a high enough velocity to escape it. What's weird is that the direction it's moving in is almost perfectly aligned with something called the ecliptic. That's the massive imaginary disk that Earth rotates on around the sun. Most planets also follow along the same pathway, give or take about 3 degrees. Except Mercury, which decided to go and be a little bit special and rotate within 7 degrees of it. Not to mention Pluto, which is inclined to it by around 17 degrees. But roughly, they rotate along this disk. Well, so does 3i Atlas. The trajectory of 3i Atlas is almost perfectly aligned with the ecliptic, just 4.89 degrees off, barely more than most of our planets. The probability of an object matching up that perfectly with the ecliptic is a minuscule 0.2%. But there's more. 3i Atlas is moving in retrograde, which means it's moving clockwise through our solar system, while the Earth and planets rotate counterclockwise or prograde around the sun. Add to that other factors like the speed, position, and timing of how our solar system's other planets travel. What you get is a seemingly very precise arrival time that puts 3i Atlas passing suspiciously close by not 1, not 2, but 3 planets, and not all that far from Earth either. It sailed by Mars on October 3rd, at just 18 million miles, 30 million kilometers, or just 0.2 astronomical units away. Mars orbiters like the ESA's ExoMars and Mars Express, plus NASA's Mars Reconnaissance Orbiter snapped pictures of it when it went by. For its next flyby, it'll reach what's called perihelion, or its closest point to the Sun. That's on October 30th. This is the time when a lot could happen. It could get hot enough to just disintegrate. If it doesn't break apart, we won't be able to see it as it passes behind the Sun, and it's not going to reappear until December. That disappearing act is when Avi Loeb says we should keep an especially close eye on it, to see if its movements hint at artificial propulsion. Next, it'll fly past Venus on November 3rd at a distance of 60 million miles, 97 million kilometers, or 0.6 AU. It'll hit its closest point to Earth just before Christmas on December 19th, at a slightly further 167 million miles, 268 million kilometers, or 1.79 AU. After that, 3i Atlas will head towards Jupiter as it makes its exit from our solar system. It's set to pass just 33 million miles, 53 million kilometers, or 0.3 AU away from the giant on March 16th. The ESA's JUICE spacecraft might also be able to see it when it does. This path is so peculiar that it's been described as a months-long sightseeing tour through our inner solar system. Keep in mind, these are vast distances for us. But in the context of flying through space, this object might as well be strolling past us close enough to bump shoulders. The numbers have been updated since Loeb's original report. Now, the likelihood of its arrival time occurring naturally is an eye-watering 0.005%. And combine that with the 0.2% probability of its trajectory from earlier, the natural odds are an even more insane 0.0001%. We've arrived at the final anomaly, number 7, which is fitting since this one goes all the way back to 1977. On August 15th of that year, a strange narrowband signal got picked up by Ohio State University's radio telescope, affectionately named Big Ear. To this day, it's one of the most mysterious signals we've ever picked up from deep space, which is saying something because there have been quite a lot. Explanations range from a sudden flare from a neutron star or a magnetar to extraterrestrial communication. Here's where 3i Atlas comes in, and it's yet another case of this object hitting the right time, right place metric almost too perfectly. Based on its trajectory, we can calculate where 3i Atlas was in the middle of August 1977, when it was about 600 astronomical units, or Earth-to-Sun distances, from our Sun. Here are its coordinates. Now compare that to where the WOW signal originated. If those numbers look suspiciously similar to you, it's because the two were separated by just 4 degrees in right ascension and 8 degrees in declination. Those are the celestial equivalents to longitude and latitude. As for the chance of 3i Atlas and WOW being that closely aligned, less than 0.6% according to Avi Loeb. There's also, the minor detail of how if WOW did come from 3i Atlas, its distance and signal strength means broadcasting that signal would have required a transmitter with a power source roughly as strong as your average nuclear reactor. Yeah. Okay, those are the anomalies. But why so much uproar over chemical compositions and trajectories, as odd as they may be? Is it just our inner robot yelling, "Danger, Will Robinson"? Have we watched too many sci-fi movies?
Danger, Will Robinson! Danger! No, Will Robinson! Danger!
Plenty of scientists, experts, and YouTubers were quick to debunk the possibility that 3i Atlas could be more than just a wandering comet. But the idea of a civilization turning a comet, or say, an asteroid, into a satellite or even a spacecraft isn't nearly as interstellar as you might think. Back in 2016, NASA gave $100,000 to a California-based space tech company called Made in Space, specifically for the first phase of a project called Reconstituting Asteroids into Mechanical Automata, or RAMA. Let me just read you the objective from NASA's website. Quote, establish the concept feasibility of using the age-old technique of analog computers and mechanisms to convert entire asteroids into enormous autonomous mechanical spacecraft. It goes on to talk about using additive manufacturing, aka 3D printing, and in situ resource utilization, a space exploration term for using the natural resources at a mission site instead of bringing them from home base. So basically, grab an asteroid, send a robot seed craft to mine its resources, and use those resources to 3D print spacecraft subsystems into the asteroid itself. As for what those subsystems look like, guidance, navigation, and control, plus propulsion and avionics. It gets better. Quote, upon completion, the asteroid will be a programmed mechanical automata carrying out a given mission objective. It continues, this technique could someday create an affordable and scalable way for NASA to achieve future roadmap items for exploring the solar system. Now, NASA gives funding to all sorts of wild ideas through its annual NIAC program. RAMA was one of 13 projects that got Phase 1 funding that year, and plenty of them just ended up dead in the water. But the NIAC is literally described as a search for visionary ideas that could transform future missions. Getting selected at all suggests the space agency sees at least some kind of potential in a project. Not to mention, the same company, Made in Space, got another $73.7 million contract from NASA just 3 years later in 2019. That was for a project demonstrating 3D printed spacecraft parts that could be assembled in orbit. Sounds awfully familiar, doesn't it? If NASA believes there's potential for creating cheap and easy spacecraft out of space rocks to explore our solar system, or maybe even beyond, who's to say another civilization couldn't do it? Especially a civilization possibly more advanced and with more energy capabilities than we have. In theory, there's also another benefit to this. Creating a spacecraft inside a space rock, well, it's going to look like a space rock, act like a space rock, have the chemical composition of a space rock. You get where I'm going with this. Essentially, it could be a really effective form of interstellar camouflage, especially from far away, where cameras and instruments might not be able to detect what's inside. Avi Loeb hints at this idea too, citing the story of the Trojan horse, except instead of the ancient Greeks using a giant wooden machine to secretly enter the city of Troy and win the war, it would be more like extraterrestrials taking an uncomfortably close peek at us without us noticing. As for why else the idea of a bizarre comet might have some people a little bit freaked out,
the sun was powerless to penetrate for 1,000 years.
Cultures around the world have been saying beware of space objects for millennia. Spotting them was considered a very, very bad omen. For example, ancient Chinese people believed comets were a warning from the heavens, that if the emperor didn't get his act together, calamity might strike him and his nation. In ancient Rome, a comet appeared in the spring of 44 BC during the festival/gladiator games held to honor Julius Caesar after his murder. His adopted son, who would later become Emperor Augustus, took it as a sign that Caesar had become a deity. Likewise, in ancient Greece, Homer's Iliad describes comets as having flaming hair that shakes down disease, pestilence, and war. The Aztecs spotted a comet in the year 1517. They believed it was a symbol of doom, and just 2 years later, Spanish conquistador Hernán Cortés arrived in the Yucatan and eventually brought on the fall of the Aztec Empire. Australian Aboriginal tribes link comets to evil magic and harbingers of death. In Christianity, the yearly Perseids meteor shower is also known as the Tears of St. Lawrence, symbolizing his suffering as a martyr. When Halley's Comet appeared in the sky in the year 66 AD, Jewish people believed it predicted the collapse of Jerusalem. That actually happened just 4 years later. The same comet showed up again in the year 1066, and it was later thought to be a sign of the Norman conquest of England and the death of King Harold II. Halley's Comet continued getting a bad rap even as recently as 1910. People were terrified that the comet would come and spew toxic gas. So they sealed their doors and windows, held their breath, and even swallowed anti-comet pills. Back to the question that's making headlines today. Is 3i Atlas aliens? Avi Loeb is the biggest voice in the debate, obviously. But I think his comments bring up two important points, and they're getting a little bit lost in all the noise. Back in August, he suggested there's a 40% chance that 3i Atlas poses a technological threat. That is not saying it's definitely, without a doubt, something artificial. He's making the point that I'd rather assume yes and get proven wrong than brush something off as a no and face consequences. He frames it like this. If you, or say your child, had a 40% chance of getting hit by a car, would you let them wander out into the road? The point is, you might want to keep your eyes open, just in case. The second, and in my personal opinion, way more important message is this. Science is a work in progress. We are constantly changing what we think we know about the cosmos, and plenty of what we think we know now could be wrong. Relatively new instruments like the James Webb Space Telescope and the Vera Rubin Observatory in Chile are already being described as rewriting our understanding of our universe, and as a new era in astronomy. That's only going to continue. And ultimately, you can't learn if you've already decided you know everything ahead of time. If we only collect or acknowledge data that fits a conclusion we decided is right beforehand, we're going to miss things. Loeb points out that human history is full of misconceived notions. He also writes that whereas the dogmatist will shove anomalous data under the carpet of traditional thinking, an open-minded scientist will be thrilled to learn something new with an underlying sense of humility. He adds that labeling space as dead isn't going to, quote, rid us of cosmic neighbors if they exist. Loeb also makes a point of saying, quote, nature is more imaginative than we are. Which is totally true, considering there are many real plants and animals here on Earth that seem like they belong in science fiction, let alone things like quantum weirdness, but that's an entirely different wormhole. If you ask me, the message is simple. We need to keep our minds open. Whether that's to the possibility of life somewhere else out there, or the simple fact that we don't know it all. If we can do just that, we might inspire curiosity, creative problem solving, and the great minds of tomorrow along the way. What do you think is really going on with 3i Atlas? Is it just a very unique space rock, or something more from a galaxy far, far away, kind of? Do you think it's connected to the WOW signal, or do you think we'll see more interstellar visitors anytime soon? A lot of you shared theories about 3i on my Planet X episode, so seriously, leave me a comment and let's talk about it. And also, go check that video out if you haven't seen it. If you enjoyed this deep dive into mysteries, myths, culture, and science, drop us a like and subscribe. Until next time, stay curious. Thank you.